Frankfurt Airport, Germany's largest airport, is getting a new terminal. Estimated cost, 4 billion euros, with a floor area of 403,000 square meters.
This is the largest construction site in Europe, the largest infrastructure project in Europe.
Infrastructure for almost 20 million passengers a year. A huge main building and 3 long boarding piers are being built for arrivals and departures. And there's more. A 69-meter high tower and the fully automated Skyline railway. It's a mega construction site. Precision is required everywhere.
I love this job because I can see things getting done. There's no standstill on a construction site.
But there are obstacles to overcome on the way to the finish line.
We've had problems with the wind the last few days. It was too strong.
Normally an aero tech should appear here now, but it's not yet fully developed.
The installation involved a few difficulties because it was actually a matter of centimeters or even millimeters.
Millimeter by millimeter, the airport terminal comes to life. The first planes are scheduled to take off in 2026.
That's the schedule, yeah. Time is running out.
The main terminal building. Construction mechanic Stefan Schmidt is checking the measurements of the tubes. They will become the heart of a special ceiling construction, where the future market hall with boutiques and bistros is taking shape.
This is a suspended ceiling with a substructure. This includes steel beams, suspension rods, and struts, to which the tubes are later attached. In the ceiling itself, there are various droplets, 3 of them, and 4 lighting elements where LED lighting will later be installed. The tubes themselves are shiny anodized aluminum tubes 40 millimeters in diameter. A total of 25 kilometers of these are installed in the ceiling.
That's a lot of tubing for a ceiling. In the end, though, this will not only look spectacular, but also focus incoming daylight to create a comfortable atmosphere for shopping and dining. The construction mechanics begin their preparations. They cut the first tube of the day to the required length of around 6 meters and mark it out. Tube number 514B is one of the more complex ones.
In this ceiling area where the tubing is used, a particularly large number of bends are necessary because these tubes angle down very steeply around the droplets. In some areas, these tubes are exactly the opposite. There, they're almost straight. So there are a lot of alternating areas on the ceiling.
The next step is the bending machine, where the data for 514B is loaded. The well-lubricated machine forms the desired curves to precision. Then, the team checks the radius with a laser measuring arm. Deviations from the construction plan in the low millimeter range are within the tolerance, but centimeters are not. Well,
we now have an average deviation of 3.7 millimeters along the measured section. So the tube would be okay in this form and could be installed as is.
It passed the test. Stefan Schmidt removes small edges and splinters, attaches the cap screw, and applies the final markings to the tube. Then, it's ready for assembly next door. Short distances are crucial.
The main reason for this is, of course, that with conventional traditional production, the tubes have to be bent in the factory and then transported to the construction site by truck. With this huge number of tubes, it is, of course, very uneconomical. That's why we decided to bring this tube bending machine here to the construction site and produce them here.
The number of truckloads is reduced to a minimum, which is good for everyone, including the environment. Industrial climbers use a boom lift to reach the assembly site at a height of 9 meters. The freshly bent tubing has to be mounted at the top of the steel beam onto the struts of the substructure so the long screws can hold it in position. Once everything is tightened, the team quickly descends again. They still have more than 2,000 tubes to go. On the other hand, lots of other construction work has already been completed. A look back. In October 2015, work begins on the mega construction site south of Frankfurt Airport, on the site of a former American military base. After 15 years of planning and approvals, the excavators can get to work. With a bucket volume of 2 cubic meters each, the machines turn the construction site into a veritable desert landscape, just outside the gates of the big city. Up to 5,500 cubic meters of earth are transported here every day. That's around 300 truckloads. The workers are excavating a pit 5.5 meters deep, located just above groundwater level. The dimensions of the pit for the future main terminal building are gigantic. Almost 70,000 cubic meters on an area the size of 9 soccer fields. The special excavation work extends to a depth of 14 meters to make room for the future building services facilities on the basement levels. To seal and stabilize the sections of land, everything is enclosed with sheet piling. More than 7,000 tons of steel will be used for this alone. Industrial divers help concrete coat the foundation at the bottom of the basin. Then, the groundwater is pumped out, purified, and put to use elsewhere. By mid-2020, the excavation pit is dry, and the first ceiling is in place. 145,000 cubic meters of concrete and 20,000 tons of reinforcing steel have been installed. Since then, Terminal 3 has been growing and taking shape. And it's larger too. For Christian Bierend, the overseeing project manager, size matters.
Once completed, Terminal 3 will handle 20 million passengers a year. This makes Terminal 3 larger than the airports in Stuttgart, Cologne, Bonn or Hamburg. We're working on an area spanning 150,000 square meters and will create a gross floor area of 409,000 square meters. In the final stage of construction, we'll have 3,000 to 4,000 people working on the site and 200 to 300 truckloads of materials delivered every day.
The main terminal building is the heart of T3. It consists of 3 parts: the check-in hall, the security checkpoint, and the market hall, from which passengers can access the new piers. The main building is fitted with a roof in 2022. The creation of the 10,000-ton Colossus is unique. The skids are removed with a crash so that the team can slide the roof segments into their final position at a height of 30 meters. A mammoth task and a decisive moment.
In fact, this is the milestone for the check-in hall, where we're saying goodbye to the shell construction work in this area. And with the steel roof, the first peg is also being driven in so interior finishing can begin in this area in the future.
The 6,000 square meter segment travels around 200 meters, pulled over 5 parallel tracks with thick steel cables. At the end of the track, there are hydraulic presses to ensure regular pulls of exactly 30 centimeters. Slide and pull, that's how it goes. Up to axle 60, where the roof comes to a halt. Apparently, several of the steel cables are too loose. Project manager Stefan Zorli is a little tense.
Maybe over the course of this length, it's a little looser than when it was put on and threaded, and when the clamp grips, it slips back a few millimeters until it grips properly. If it gets really bad, you would have to try to pull it back somehow, or pull more on the one track where it is jammed.
Below, Christian Nott's ground crew is at work. For 25 years, he and his team have been something of an emergency squad on steel construction sites. The workers open all the existing connections and pull the cables back to the same tension. This creates even tension at the top too.
It's always difficult for everyone at the beginning. It's not something you do every day, that's for sure. And that's where we have our doubts. Will everything fit?
Everything fits. The roof segment makes it most of the way during the night. The following day, it reaches its final position. 4 more sections will be pushed into position over the next few months. The main terminal building now has a complete roof. From here, passengers will soon be able to access Pier J, where the particularly long planes can park, as well as Piers H and G. In between, the 69-meter-high apron control tower will be the next eye-catcher, and an extremely high-visibility workplace for the controllers who will manage all the ground traffic at Terminal 3 in the future, deciding who can move where and when across the apron. The tower is being erected using what is called a climbing formwork. This involves a crane lifting the pre-assembled formwork modules of the outer wall 1 story higher at a time. A new floor is being built every 2 to 3 weeks. At these heights, however, vigilance is extremely important.
Hey! Railing! Railing!
As soon as the formwork has been installed, the next elements and scaffolding follow. High above, on floors 13 and 14, project manager Sebastian Wolber and his team are getting ready to place the control room for the apron controllers, which will later protrude 6 meters beyond the base of the tower. The goal is to provide an unobstructed 300-degree view of the apron, with the glass panes positioned at an angle all around to eliminate virtually any glare.
That is certainly the trickiest part of the whole project up here. Installing the large facade elements, then angling them and making all the connections we need to attach them to the building.
It takes a whole year until the tower is ready for the installation of the glass panes. Now, under the supervision of construction manager Benedikt Goldbach, they will be installed one at a time at the top of the control room. And that, as it turns out, is no less tricky.
We've had some problems with the wind over the last few days. It's been too strong. We've even lost a whole day at times. Fortunately, we were able to make up for that. But the glass pane can turn at the top, and that's the biggest challenge we face.
If the wind speed exceeds 5 meters per second, work must stop immediately. This can theoretically happen at any time.
The glass pane is 3 meters 30 high, 3 meters wide, and 65 millimeters thick. We have triple glazing here, which means an outer pane, an inner pane made of safety glass, and a tempered pane in the middle. In between, we have spaces for inert gases that provide thermal insulation. And a pane like this weighs 870 kilos. So the only way to lift it is using a suction system like the one we use here, and then guiding it up to the control room.
The suction system is attached to the crane. It holds each pane in place during transport to the control room at a height of more than 60 meters, where fitters receive and align them. The suction system extends fully at the top and carefully guides the glass element to the building. A second, somewhat smaller suction system is installed in the control room and takes over the valuable cargo. Afterwards, manpower is called for again. Each pane has to be screwed into place 50 times. In addition to the crane operator, a total of 10 facade builders and 4 scaffolders are on the job. They all have the ambitious goal of installing at least 3 window panes a day in order to winterize the building as quickly as possible.
Now the assembly for the next element is prepared. The scaffolding is moved. This means that one panel is now moved to a further position, and then it's attached to the ceiling at the top and can then be mounted in place. Then comes the next panel.
Scheibe.
With the start of the interior finishing, these glass panes will finally be prepared for optimum visibility. An additional interior finish will give controllers an unrestricted view of the apron. The new 5.6-kilometer-long route of the Skyline train. Passengers can use it to reach Terminal 3 in just 8 minutes from the long-distance and regional train stations. The starting point is a new station at Terminal 1. 12 trains run from north to south, each equipped with 2 cars, one of which is always reserved for non-EU passengers. The first stop, Terminal 2, where passengers disembark, transfer, or board. And this is where the existing Skyline station is being widened by 2 lanes. Passengers change to the new train. The train travels to Terminal 3 every 2 minutes at 80 kilometers per hour, with no driver. The new T3 station is 150 meters long and 30 meters wide. It has 2 tracks, so that 4,000 passengers per hour can arrive and depart at the same time. Because the trains have to bypass the existing apron, the new 2-lane route runs close to Highway A5. Only a good 2 kilometers of the rail line are at ground level. The easy part for the builders. 3.5 kilometers, however, run over elaborately constructed supports and almost 200 track girders. Almost every one of these has a different shape and weight, and yet has to fit perfectly at heights of up to 18 meters. This means several years of complex lifting and installation work at any time, day or night, and then it's done.
The installation presented a few difficulties because it was actually a matter of centimeters or millimeters. Ultimately, we got the job done. It was a bit of a pain. It's cold, but I'm glad it worked.
With the frame in place, now it's time for the track. But before all the system installations are put in place, Skyline project manager Wolfgang Holzhausen checks the height of the track.
Here we see this one track that has the 2 lanes for the 2 rubber tires. We have a rubber-tired system on a concrete track. Here it's inclined slightly inward so that the water drains inward. And we also see these drains here which connect to the bridge drainage system underneath. We collect all the water so that it doesn't run down erratically. What we can also see here is the junction for the cables to heat the track, so it can be put to full use in the winter as well.
Ready to go around the clock. This convenient garage is also part of it. A 7-story workshop building for maintenance, cleaning and repairs is being built on a high level between Terminals 2 and 3. And for a spare parts warehouse, so these modern trains can always get back on track quickly. The time has finally come. The first car rolls in. Not on its own just yet, but on a low-bed truck from Austria.
This is a milestone for us because, of course, the vehicle is the heart of a transportation system like this. The vehicle is also what our passengers will later experience in the truest sense of the word. So, of course, it's particularly important to have the vehicle here now and to finally be able to see it.
Each train has a counterpart, to which it will later be connected via a joint and a corridor connection, just like a streetcar. The 12 pairs of cars are real heavyweights. They each weigh 32 tons on the tracks where they will travel fully automatically later on. But first, the workers have to unload vehicle number 1 and put it on its own feet. And that seems to be anything but easy.
The special thing here in Frankfurt is that we're lifting the vehicle up onto a viaduct. So we're 18 meters up. And that's something very special, especially with all the safety precautions. So you have to make sure that all employees work safely, behave safely, and although the weather isn't exactly ideal for unloading, unfortunately that's part of it.
Things are moving in Frankfurt, but not really fast. The car is only moving slowly in the right direction. It's 22.4 meters long, 2.8 meters wide, and 3.7 meters high, identical to all the others that have yet to arrive. And at more than 30 tons, it's also really heavy.
These dimensions, together with the weight, also means that it is a major challenge to transport the vehicle from the vehicle plant in Vienna to Frankfurt Airport. Starting with road transport, lifting it onto the track in a confined space, and then rolling it into the workshop building.
There's strength in tranquility. Car number 1 is placed safely on its own wheels without any scratches. The newcomer will now undergo numerous static tests in the workshop building before it can go out onto the track for its very first test drive. 23 more cars will now gradually be delivered and readied in dry conditions for continuous use. The interior work begins in the tower. To do this, the workers have to move numerous machines and lots of materials up. Nothing works here without them, the elevators. Still a little bare, but in the middle of the mega construction site, they're already in continuous operation. Christoph Borbe and his team are responsible for the installation and functionality of all elevators at T3. There are almost 100 of them. Most of them will provide vertical access to the 7-story main building, with a load capacity of up to 6.5 tons. But the current error message comes from an elevator here in the control tower, of all places. An alarm that has to be responded to immediately.
This is always something special. The tallest building at Terminal 3, 70 meters shaft height, 56 meters hoisting height, speed 1.6 meters, and of course, it's a fire department elevator under the special requirements of the Frankfurt Fire Department.
Fire department elevators are specially secured and equipped with viewing windows. They can also be used in the event of a fire, ideally by the firefighters themselves. Elevator technician Christian Fitzka is currently in charge of 12 systems that are in so-called construction operation and already running on the power grid. Only here, things are not running smoothly. To prevent downtime on the construction site, the malfunction has to be eliminated as quickly as possible. Christian Fitzka locks the elevator and first takes a thorough look at the moving parts. This is followed by several test runs over the full 70 meters of the shaft. Even a veteran has to keep in mind that this is not an everyday job site. Of course, things can happen here.
It's dangerous, so you shouldn't approach the job recklessly, even if you've been doing it for years. You have to pay attention to safety. And here, for example, you can see that there are railings. Of course, you shouldn't climb on them or lean out. There are rotating parts. It's the ropes that whiz past you. So sticking your hand out, sticking your head out is not a great idea.
Incidentally, people in the trade only talk about elevators and not about moving chairs. The latter term in German, Fahrstühle, is rather flippant and dates back to the obese Empress Maria Theresa in Vienna, who instructed her servants at Schönbrunn Palace to pull her up to the upper floors with a chair so that she wouldn't have to climb any stairs herself. This fire department elevator is definitely more than just a pulled chair. Meanwhile, Christian Fitzka can report that the defective elevator will be running again very soon.
Well, the maintenance has now revealed that it was missing a drop or two of oil, so it's not yet at the minimum. This will be taken care of during the next servicing, when it will be refilled. I checked for the malfunction and the belt was a bit loose. It's been tightened and now the door closes properly again, and it won't pose a problem anymore.
Major maintenance is carried out once a month. And every tiny fault is meticulously recorded and fixed.
And
So I've completed the maintenance and so far the system is free of defects.
Around-the-clock support is guaranteed for this important facility even after the mega construction work on Terminal 3 has been completed.
after the construction phase of Terminal 3, when the shell is finished, we'll dismantle the elevator as a construction elevator and then fit it with the final lining. And then prepare it for fire department approval, and then of course the tower can also go into operation, so aeroplanes can drive on the apron and land.
Christian Fitzka will remain the service and contact person here in the future, including for the controllers in charge of traffic on the apron. The fire department elevator takes them to their workplace. The elevators for travelers in the main building are fully glazed. Soon, they will offer spectacular views of the check-in hall. However, heights are also overcome here by installing extra-wide inclined moving walkways. With an incline of 12 degrees, a first in Germany. The special approval is due not only to the expected load of passengers with luggage trolleys, but also to the 8-meter difference in height that has to be overcome on the rather short distance. The fact that the building shell has now progressed rapidly is a real challenge for the elevator company. Getting the remaining total of 92 escalators into the building is complicated. Precision work. This 1.5-ton precast element is supposed to pass through this tiny opening. 2 meters wide, 3 meters 50 high. To prepare, temporary support elements weighing several tons are installed on the ceiling. At a height of 12 meters, 2 cranes lift the freight, which is 15 meters long, through the eye of the needle.
Slower.
Careful, nothing must be bumped. No scratches on the black paintwork. As soon as the custom-made escalator arrives at its destination, the team can breathe a sigh of relief.
Yep, it fits.
The 600-meter-long Pier J is designed for passengers from the non-EU countries. 28,000 square meters of floor space on 3 levels, with the uppermost ceiling projecting above the 86 stylish Y-shaped columns. Maximilian Kellermann's team initially erected 8 substructures close together and is now connecting them, using various prefabricated elements weighing several tons, among other things.
Pier J is characterized by this special mix, a hybrid mixture of in-situ concrete, shell construction with formwork, and reinforcement on-site, and over 4,000 prefabricated parts, which are prepared in advance in other plants elsewhere, concreted and delivered to the construction site by truck and then assembled with the shell construction on-site.
A crane lifts an exterior column to level 3, where 2 workers take delivery and briefly put them in temporary storage. Once it has been reattached, each column is transported upright to the installation site, where workers place them on the fixtures and tighten them in place. This interface between the precast element and the in-situ concrete must fit exactly. Once the column is stable and straight, it can be wrapped in film after a final inspection to protect it from wind, weather, and construction dust, followed by the next precast element. Everything at Pier G already looks nearly complete. This is because the pier was actually supposed to be completed first and open with its 22 check-in desks and 13 gates before the other 2 piers. But the coronavirus pandemic and the associated extreme drop in passenger numbers rendered that plan superfluous, at least until now. For project manager Ilma Celio, this means that everything has to go faster here at Pier G in order to be ready for an early start at any time.
The challenge in Pier G is that, due to our shortened construction time, an incredible amount of work has to be carried out simultaneously. We're laying the screed and installing the ceiling radiant cooling panels at the same time. Meanwhile, the roof is being waterproofed, and it all has to be coordinated to keep up with the construction schedule.
The architectural highlight can be found in the main building. 3 huge round skylights provide plenty of light in the pier. Over the 400 meters of Pier G, 20,000 meters of heating and cooling pipes are required, 9,500 meters of ventilation ducts, and a total of 160,000 cubic meters of screed are laid. All the work has now been completed. Project manager Felix Wegmann is responsible for the connection between Pier G and the main terminal building. The early completion of the pier complicates matters.
We now have the situation that we have a completed Pier G, which could go into operation tomorrow, so to speak. And on the other hand, we have the main terminal building where the shell has already been completed and the expansion is currently underway, and where we now face the challenge of having to erect another shell at this interface, so to speak. We are now connecting our floor slab or foundation work to components that have already been constructed.
The workers here now have to use 4 construction cranes to ensure that the main building of Terminal 3 is connected to Pier G.
Pier G, what you see here now, this corrugated metal facade, is a temporary partition. This corrugated metal facade will be dismantled, as will the masonry behind it. The actual Pier G walkway ends, I'd say, on a line with the building construction cranes. This means that the facade will be at the end of the building, and at the back here we can see the canyon road, which will remain in place later. So, Pier G is not directly connected to the main terminal building.
Future travelers will be able to go from one building to the next via airside connecting bridges. For Felix Wegmann, it's down to ground level, level 00.
A construction site, no matter where, always starts in the ground. You build from the bottom up. This means that the first measures we take are the earthworks. You do the leveling, make the subbase, lay the foundations. In our case, these are mostly sleeve foundations because we work with prefabricated elements.
Everything is being prepared for the next arrival of huge prefabricated elements. These also have to fit in perfectly with everything that other companies have already built and bolted together. No small feat, being the gap filler on Terminal 3.
We're not building on a site in open countryside, but connecting various components that have already been built in advance. And we have to keep checking to see whether the preliminary work fits. For example, here is the finished ceiling of the cable duct. And you can see screw connections at the front. Reinforced steel is screwed into these connections. And this is also connected to a structure already built in advance.
Reinforcing, pouring concrete, and building on and on. The main building will still take some time. The 2-story Pier H for the EU countries is the 3rd pier in Terminal 3. Just as long as Pier G, but still a long way off. Although it looks pretty complete from the outside, project manager Tim Knief still has a number of construction sites to inspect on the inside, especially on level 2.
This is ultimately the level that's time critical for the project. We always talk about line construction sites, a term kind of borrowed from track construction with a very narrow construction area and a very long construction area. Here we have 400 meters of pier with all the finishing work involved.
At the moment, however, the front section of the 25-meter-wide pier mainly offers huge storage areas where material is temporarily stored. The red steel structures for the so-called PAX boxes can already be seen in the middle of the pier. These will be the central components of Piers H and J. They will later house stores and restroom facilities, for example. Each of the 12 steel boxes of Pier H will weigh at least 10 tons. Transportation and assembly are challenging, and thus one of Tim Knief's main priorities since the workers can only continue with the floor once the structures are complete.
At first, we assumed that we'd have 12 PAX boxes where we could work in series, planning complete, deadline set, and so on. However, we realized that all 12 are ultimately individual prototypes because the structure always differs in terms of the requirements here at the airport, with the various areas such as retail, toilets, or combined zones.
Due to the construction as a line construction site, all trades are working one after the other on different sections. The further along the pier one goes, the more visible the progress becomes. Progress is also being made on the ground, layer by layer.
The electrical ducts have been installed with the preparations for the floor tanks, and the first subconcrete covering the ducts has also been largely installed. A separating layer is now being laid. The underfloor heating will then be laid on the separating layer. A screed is then laid on top of the underfloor heating, and the natural stone floor is then laid on top of the screed. This is a special floor structure that has proven itself over the last 20 or 30 years here at Frankfurt Airport.
The spectacularly shaped underfloor heating is still a visual highlight, but it will soon vanish beneath the screed and natural stone. And after commissioning, it will run almost 24 hours a day. The central air conditioning unit in the basement of the main terminal building is responsible for the supply. This centerpiece essentially consists of two identical heating and cooling power centers, WKE West and WKE East for short. Technical project manager Jörg Sassen has an eye on the construction of both and closely monitors the welding and insulation work.
So we're almost finished here. There are a few little things to take care of, and then we can start it up. Lots of things can go wrong, starting with pumps that are too small, maybe not correctly connected, insulation not installed correctly, various things. Sometimes it's just little things.
Small things that can have a big impact. No traveler should freeze or sweat, even if they miss their flight. 4.5 kilometers of copper, steel, and stainless steel pipes will carry heat and cooling to all of the buildings in Terminal 3. Each control center will have 7 cooling units, which will generate enough power to easily supply 4,000 single-family homes. And on many roofs, not only large photovoltaic systems will later be installed, but also modern recooling plants and a heat recovery system.
We use the waste heat from the ventilation systems, from the baggage handling systems. That is, wherever energy is generated, including by people in the terminals, the heat is fed back into the system.
If the calculation is right, in a mild winter, this waste heat will be sufficient to cover all the heating requirements of Terminal 3. Back to the market hall, where installation of the nearly 100-meter-long ceiling construction is now complete. The tubes weigh around 8 tons and offer lots of superlatives. Peter Grieskamp was involved in the planning from the very beginning. He knows every tube, but also every problem that the construction of this architectural highlight entailed.
In total, we installed almost 3,000 tubes, all around 6 meters long, a total of 18 kilometers of finished tubes. Each tube is unique, of course. The challenge here was also to say, okay, which tube goes where, to have the numbering, and also to say, all right, what's the sequence from tube to tube?
High up, the work ran smoothly, tube for tube. But the substructure called for a certain amount of inventiveness.
Exactly here in the arch area of the rotunda, there was a lot of reinforcement, that is steel, embedded in the concrete, which is not always visible on the plans. And the problem we ran into here was that we couldn't really get the dowels we'd planned for this into any of them because the drill always hit iron. Of course, we weren't allowed to drill through the reinforcement, so we had to devise something during the construction phase to get these brackets onto the concrete. We drilled 20 holes here and kept trying until we really found a free spot.
In the end, the team knew how to help themselves with assembly templates. Everything now floats spectacularly, held securely and firmly in place. Even the 3 striking droplet structures that bring daylight into the market hall, they weigh 4 tons.
The funnels were a real challenge. We installed 1,700 different sheets here. Each triangle is unique, all riveted together from the top in large sections to the bottom in very small sections. And when the first funnel was installed, we said, there's not much that can go wrong now.
The result is a ceiling with a wow effect, an eye-catcher. The stores downstairs will have to work hard to keep up. On Pier H, the team's current focus is on the 10 bridge structures that span the roadway. The steel structures are self-supporting and are the connecting element between the fixed pier and the movable passenger boarding bridge. The H2 bridge structure already gives a good indication of where the journey is heading. The shape and color have their final look. The window panes are in place. The doors are being installed. Project manager Tim Knief can already test the passenger routes. At the end of this corridor, the mobile passenger boarding bridges will provide access to the waiting aircraft once they are operational. Surprisingly, however, a plane is already parked here, 2.5 years before Terminal 3 is scheduled to open.
Here at Frankfurt Airport, we're always short of the necessary capacities for flight operations, takeoff and landing. But the main focus is also on the positions on the ground. We always see aircraft from Asia landing here in the evening, where they park before taking off again the next morning, in the normal turnaround. And it's extremely important for flight operations here that the positions at the piers are already largely in operation.
Pier H has changed a lot in 6 months. The PAX boxes in the middle of the pier, in particular, are becoming a reality. 8 of the 12 steel boxes are to be rented out as flexibly configurable spaces. The workers are building a predefined shell that can later be designed by the respective tenant. The red of the original construction is rapidly disappearing.
The red steel structure as a lightweight construction is now connected to the curtain-type glass facades and the canopy construction, which is already finished apart from the cladding on the top and bottom. The first area behind this curved glass facade will be one of the smoking lounges that we have here at Pier H. And on the other side, in the PAX box, we've already completed a tenant floor area, so to speak, for tenant construction.
Work on the underfloor heating and screed has now been completed. Now it's time for the final layers on the floor and walls. The decision makers chose Turkish natural stone for the wall cladding and Jura lime from a Bavarian quarry for the floor. A total of 10,000 square meters will be laid here, in Pier J, and in the main terminal building.
The natural stone is now being laid in 2 teams. Around 50 people are working on the natural stone here. You can clearly see the area where the stone is being laid, glued and grouted. And by using a quick setting adhesive, we can put the protection back on the finished floor after just 1 week, so that the next workman can continue working on the ceiling and walls or in the PAX boxes.
There is not much hustle and bustle in the main terminal building at the moment. But project manager Sven Fuchs knows that this will change by the time it opens in 2026 at the latest. When passengers reach Terminal 3 by Skyline train or car, this is exactly where they will arrive. The check-in hall is the entrance to the new terminal. The first impression should definitely be right. At a height of 18 meters, the roof has now been completed, as has the glass facade. More than 700 glass panes, each weighing 700 kilograms, give the huge space an airy feel.
Architecture of the check-in hall has been designed in such a way that we have a large hall area that is flooded with light, that is open, that doesn't feel crowded. The bend is also particularly important. This also has something to do with radar radiation. That had to be planned in accordingly. It also gives the entire building its own touch, its uniqueness.
The bend in the optics also provides added daylight. But a flashlight is still needed to check the fixtures in the floor. Heating and cooling. A large area of underfloor heating is also installed here, far from everything that runs underfoot.
We are in the process of building the so-called system floor. That is the lowest level, and will later conceal all the technical installations of the check-in hall, be it ventilation, be it electrical, the IT connections, everything that goes with it, so that people can work here and it will be fully functional.
The infrastructure has to be created now so that the processes will actually work later. The recesses for the 3 check-in islands, where travelers will also check in their luggage, are also clearly visible.
A separate steel structure will be erected for the check-in counters, in which all the equipment, computers, displays, etc. will then be installed. In the distant background, we can also see the opening where the baggage is transported to the baggage handling system and then distributed throughout the rest of the building. If you then press forward, the system normally starts up.
Here on level EUZ2 at the baggage handling system in the main terminal building, everything is still brand new. Project manager Isabelle Silvery gets an update. 3 kilometers of conveyor belts have already been installed. It's just the beginning, as there are still 12 more kilometers to go.
The baggage handling system is currently in the assembly and installation phase, and it's also being commissioned. This means first we're connecting the electrical power supply, and then, section by section, we're testing the drive systems and sensors for manual and automatic operation.
Checked baggage will later be transported to the destination in containers over several floors.
The baggage handling systems consist of many individual modules. These are standardized from switches to lifters. We have a total of several thousand system elements, which are driven by around 15,000 drive units.
Here, in the distribution area, new functions have been implemented on the control cabinets. These are the very first tests that planning manager Siegfried Erndt is carrying out. Much of this is automated. Only the basic commands are entered by the operator.
Now pre-select it.
Press it longer. Okay.
Exactly. This is jog mode. This means that it only moves while you hold it down with your finger.
So this is manual mode.
And off we go.
Isabelle Silvery makes sure that Siegfried Erndt also tests how fail-prone the system in this segment is. So, a problem is simulated.
So if we stop this one, look, malfunction.
Can I see on the display what the problem is?
Yeah, an error text should appear now, but it looks like the system is not doing that yet.
The software needs to be improved. Other than that, it works smoothly as the bins shoot past. Each piece of luggage should make it from the drop-off point to the pickup point in just 8 minutes. The future passenger likes to hear that.
Another special feature is that we travel at a top speed of 2.5 meters per second, which means that we can reach our destination within 2 to 3 minutes from the point of departure for transfer luggage, which sometimes has a tight schedule.
Destination reached. Terminal 3 is due to open in 2026. Then the Skyline train will finally be able to shuttle passengers. They will check in their bulky luggage in the check-in hall, probably marvel at the droplet ceiling in the market hall, stroll across the main building to Pier G, or reach their departure at one of the other 2 piers. The controllers in the apron control tower clear the runway, and then from the aircraft window, the passengers look down on a spectacular airport terminal where there is no more trace of the mega construction site.